Okay, let's take a look at 4.2, which is adding and subtracting matrices. So in this section, what are we learning? We are learning how to add and subtract matrices, and then we're going to also use those skills of adding and subtracting to be able to solve certain matrices. Not every single one, but certain ones if they match up. All right, so new vocab: matrix addition, zero matrix, matrix equation, and equal matrices are the phrases we're going to be looking for throughout this chapter. So be on the lookout for those as we're moving forward. All right, so first things first, skills that we're going to need. You got to be able to simplify all of these. And so just for example, this is a 2 by 2 matrix. It would turn into, number 1, 10 plus 4 would be 14, 0 plus 4 is 4, negative 2 plus 4 is 2, negative 5 plus 4 is negative 1. And so that's our simplified matrix for number 1. Go ahead and clean up 2 through 6 for me, and then keep moving once you're ready. All right, so let's take a look at adding and subtracting matrices. So sometimes you're going to have multiple matrices that you want to put together to get new info. All right, and so matrix addition is how we're going to do that. And it works pretty much the same way as just regular addition, as long as you keep things lined up. All right, so here we've got some information about SAT scores. We've got scores for guys and girls, for verbal and math. All right, so what we could do is create one matrix out of this set of information for verbal, which we've got over here, and then another one for math, which we've written right down here. And then what if we wanted to know the combined SAT scores, right? So we could add each together. So if we wanted to put the combined 1995 male scores, we're going to add the ones that line up, 505 plus 525. And you'll notice that's right here. They've inverted the matrices to have the years on the top, but that's fine. And you're just going to combine them and add like normal. All right, so just like in our skills check here, we're just simplifying every single piece of our matrix. 507 plus 530, you get 1037. And so we can just add, just like we normally would, just multiple times in multiple spots. All right, so see if you can do the same thing and clean up A and B to find the sum for each problem. All right, so you've seen here that with matrix addition, here's just the formula. If we have, first things first, the matrices have to have the same dimensions. You cannot add matrices that are not the same sizes. Got to have the same dimensions. If they are the same dimensions, then it's just adding the numbers that are from the same location. So A plus R would be our sum of A and R here. All right, we'll put them together. So now we have this new phrase, the zero matrix. All right, so that's what we would use to say like we're just staying the same, timesing by 1. So if I have a, let's call it a 2 by 3 matrix. So 2, 4, 6, 1, 2, 3. Right? The zero matrix that would match up with that would be a matrix of the same size with 0 in every single spot. So that if we added these two things together, our final answer would be just our original matrix, because every single number would have been added plus 0, so it wouldn't have changed. All right? So this guy right here is what we call the zero matrix. All right? Useful in a couple places. All right, so find each sum using identity and inverse matrices. So the identity matrix is the zero matrix. You'll see here that if we add 0 everywhere, we stay exactly the same. 1 stayed as 1, negative 7 stayed as negative 7. When we want to do the inverse matrix, we're going to figure out, okay, what numbers would we need to take our original numbers and turn them into 0? So what cancels out 2? The inverse of 2, which is negative 2. What cancels out negative 3? The inverse, which is 3. All right? So see if you can find the sum of both of these. I bet you it's either going to involve inverses or identities, zeros. All right, so this slide here, and this is from your book, all this is saying is that anything that we can do with normal addition, with normal numbers, we can do with matrices as well, as long as, and here's the key, all our matrices are the same size. So as long as all our matrices are the same size, we're just going to do normal addition. Okay? Now we're going to move into subtraction. Same thing as regular subtraction. To subtract two numbers, it's the same as adding the opposite sign. Alright, so here, 3 minus 1, you can think about it two ways. Either 3 plus negative 1, or you could say 3 minus 1. Either way, you're going to end up with 2. Alright, 0 minus 4 is the same thing as 0 plus negative 4. You're going to get negative 4. Okay? Or you can just go subtraction. Just be careful with your signs. Like right here, negative 1 minus negative 2 is the same as saying negative 1 plus 2, and you'll end up with 1. Alright, so subtraction, the same way as normal subtraction. Just keep things lined up inside your matrices. So go ahead and try A and B. Make sure you can subtract both of these matrices. Alright, so now we're going to use what we know about addition and subtracting matrices to solve for them. So here's our problem. X minus this matrix equals this other matrix. We want to get x by itself. We're going to do it the same way. If we had this problem, just making one up, if we had x minus 5 equals 10, we would add 5 to both sides. We're going to do the same thing here. To cancel out this minus, we're going to add it. But if we do it on one side, we got to do it on the other side. So now x equals 0 plus 1 is 1. 9 plus 2 is 11, right? We're going to do it in all the spots. And so this would be our final answer. See if you can use the same thinking to figure out what the X matrix is for problem 4. All right, now matrices are only equal to each other if every number is the same in every single spot. So let's see if A is equal to B here. Is negative 0.75 the same as negative 3/4? Yes. Is 1/5 the same as 0.2? Yes. Is 1/2 the same as 0.5? Yes. And is negative 2 the same as negative 2? Yes, it is. Aha. A and B are equal. Let's check on X and Y. Negative 1 match up with 4 minus 5? Yeah. 2/3 with 0.6666666? Yes. Is 2.5 the same as 5 over 2? Yes. 0 and 0. 1.5 and 1. Nope. 1.5 and 1 are not the same. So because these are not the same, the whole thing is not equal to each other. And there's actually another spot here. Negative 5 over 6 is not the same as 2 over 3. They don't reduce the same way. So X and Y, they have the same dimensions, but they are not equal matrices. Please tell me if A and B are, these two matrices are equal to each other. And for B, are these two matrices equal to each other? All right, number 6. If we want to find unknown parts of a matrix, we're just going to match it up. So I want to find x. I know that 2x minus 5 must correspond with 25. So 2x minus 5 equals 25. And so we can figure out what x is. Same thing here. We're missing a variable here, 3y plus 12. That's going to equal y plus 18. So we can set that up. We can move y's around, the 12 up to the other side. Y is going to equal 3. All right, so just corresponding spots are going to be equal to each other. Last part here, see if you can solve for x and y. See if you can solve for x and y. And that's it. Any questions, please let me know in class.